Right. I'm cutting up this stream into multiple videos so that they can all serve as individual tutorials that people can watch. So if you are joining this as a video happening, if you're watching this as a separate video, what you've missed is that in the previous video I set up OpenGL and GLFW in a CMake project to be able to render some pixel data on the screen. So I'll show you what that looks like. It looks like this. We open up a window with Hello World as the title, and we've got this 100 by 100 pixel texture with our pixel data. So what I did is I gave OpenGL, don't save that. So it might look like it doesn't make any. It's a bit chaotic right now, but in general, up here, we have the essential part, which is I'm allocating a buffer of 100 by 100 by 3 bytes. So we have 100 pixels wide, 100 pixels high, and each pixel has 3 bytes. And then with this code here, I'm filling in every pixel the red, the green, and the blue component to have all red and no green, no blue. And then here, in a different range, Y ranging from 25 to 75 and X ranging from 25 to 75, I'm filling in only blue pixels. So what we get in this data buffer is an image with like everything red and then the center being this blue square. And then the code that I've made earlier is that I load that into OpenGL as a texture. So then we have our texture handle that we can then print to the screen whenever we want. So then I bind that texture and I draw it at these coordinates. So that's what we've got in the project. What I want to do in this one is start decoding a video file and get out the first frame of the video file and try and get that on the screen. So that will involve initially setting up initially setting up FFmpeg to start working with that library to start getting information about our video file. So I'm gonna quickly commit this. Commit all my changes. Git commit everything with the message pixel data rendered through texture. Okay, so how do we set up OpenGL? It's again, first, whatever operating system you're on, you have to install, not OpenGL. How do we set up FFmpeg? You have to install FFmpeg onto your system. And so the way I do that is just with brew install FFmpeg. And that will download FFmpeg, but it will also download all of the dependencies for FFmpeg. And FFmpeg is actually broken down into, externally you can use it as this command line tool to convert audio and video files, but internally it has a whole collection of libraries that together form the FFmpeg functionality. Namely, there's livavcodec, like internally it's called libav. So yeah, libav here. This is the library that underpins all of the functionality of FFmpeg. And it consists of avcodec, which is a library filled with different encoders and decoders for video files. It has avformat, which contains all the code for taking video data outside of containers, outside of the format. So if we look at a video file over here, so I have, let me open this up. So I have my demo song. If I get information about this demo song, it is an MP4 file. And so MP4 is the container or the format. And inside that MP4 file, there are different streams placed inside the file. There's audio data, and there's video data. Namely, what this more information is giving me is that there's stereo audio channels. So there's a stereo track of audio with the codec AAC, which is like Apple's audio format. And then we have H.264, which is the codec for the video data, which is 1920 by 1080. So inside a format, an MP4 container, you'll have multiple bits of multiple streams or packets or data. And inside there, you can also have like subtitle information. You can have metadata of like where it was made, who made it, the last time it was edited, what software it was rendered with or exported with. Lots of stuff can be put inside that file. You can also have multiple video files at multiple resolutions. You can do all sorts of weird, like the stuff inside, the way video file data is placed inside a file is quite complicated. And libavformat is responsible for that. Next, you also have like libavfilter, avdevice, avutil. And so there are a whole collection of libraries that are used inside FFmpeg to make it do all those things. We're mostly going to be focusing on using avcodec, avformat, and avutil, which provides a few utility functions to make things easier. But first things first, we've installed it through Brew. How do we start using it in our project? Well, another thing I want to install, which will make this all easier is package config. So yeah, it's already installed on my computer, but that's what you need to do. Brew install package config. When you install FFmpeg globally on your computer, it will put the different library files, the files that your project has to link with and connect with to be able to run, it will store them in different locations. And package config is a tool that helps you locate where all those libraries are and gives CMake the information it needs to know where FFmpeg is and how to fit it into your application. So we're going to be using package config to create our library, to link with FFmpeg. How I like to do this is every library I use in my project, I have a folder for it. So inside lib, I've got glfw, which we're using for the rendering of graphics. I'm going to make a new folder called FFmpeg. And instead of any of the code being inside there, I'm just going to put one CMake lists file in there. And all the code, all the CMake information that I need to link and connect with FFmpeg, I'm going to put that in this one file. And then from our main CMake file, all I have to do is say add subdirectory lib FFmpeg or lib ff capitalized mpeg. And then when it comes to linking the libraries, glfw extra libs, and I link with FFmpeg like that. I want to make it super simple so that like we hide all of the complications of linking with FFmpeg. So how do we link with FFmpeg? In the beginning of this file, again, I want to say the minimum required version of CMake, so that CMake knows that I'm like what version of itself is needed to understand this file. And I'm going to start a new project called FFmpeg. And inside here, I'm going to find the package config. And it's required. I need to use package config. By saying this, from here on forward, we can use package config functions inside CMake to help us find FFmpeg. It's weird. We have to find package config to then find FFmpeg, but it works. So we're going to use a function here called package check modules. And I'm going to say I want to look required imported target libavcodec. So that's the name of the library, libavcodec. I want to find this on my system, and it's required. I need it, and it's going to be an imported target. And internally in CMake, I want to refer to it as capitalized avcodec for now. And I want to do the same thing for avformat, which on my system should be called avformat. And I want to do the same thing again for avfilter, avdevice. I just want to link with everything, even though I might not use all of them right now. Lib avdevice. What else do I need? Avutil. Now, it might be that you don't need all of these libraries and then you don't need to link against them. But my assumption is that if you're going to have avcodec on your computer, that's because you installed all of FFmpeg, which means you would have all of these libraries. So it's not really, I wouldn't expect to see a situation where people don't have all of the libraries installed. But if you're preparing your executable in a specific way and you want it to be as small as possible, then only use the libraries that you need. But I'm just going to use all of it. So I also want these two special libraries called SW resample and SW scale. Actually, I don't need SW resample, but again, I'm going to link all of them just for brevity. Okay, so we've got package config to search and find information about all of those files, and to make sure that it has to find all of those, not files, all of those libraries. And now I'm going to say a library. I'm going to create a library in CMake. I'm going to say my library is called FFmpeg, and it's an interface. It's not an actual library, but I want people in other CMake list files to be able to treat it as if it's just a library that you can link. So it's going to be an interface that's imported, and I want to say, okay, within that library, there will be certain header files that I need to include. And so then I'm going to go through avcodec include dirs, all of the include dirs for avcodec, for avformat, for avfilter, for avdevice, SW resample, and then SW sample, SW scale. So if package config finds these libraries, it will create variables inside CMake like avcodec include dirs, which will have all of the directories that need to be included by someone who wants to use that library. So we want to attach that to our new library FFmpeg so that everything that's needed to run FFmpeg will be prepared for us. So we need that, and then we need to set our link options for FFmpeg to link with all of the libraries. So avcodec LD flags, avformat LD flags. There must be a faster way to do this. All right, like this. LD flags. Okay. That's our FFmpeg library. Let's see if that works. So we add that as a subdirectory, which opens our CMake lists file, and then we link it with our video app. I think that should work. Let's see. Okay, so there's an error here, but before we look at the error, so it found package config, good, and then package config was trying to find all these modules, and it found libavcodec with a certain version, libavformat with a certain version. The only one it didn't find was rescale. That's wrong. It's libswscale, not rescale. Just like that, swscale. So that was just a typo. There we go. So configuration done, build files, we built it all. So now inside here, can we compile this? Yeah, cool. So let's start writing something with FFmpeg. We've now got an executable that's linking with FFmpeg, so it should be able to call some functions with FFmpeg and open a video file. I'm going to commit this again. Linked with FFmpeg. So this repository is available in the description. You can clone this and use this yourself. You can copy out files. There's no license. You can do whatever you want with it. Yeah, so that's the way I got FFmpeg to run and link. It took me ages to figure this one out, but that's the simplest way I could do it. Package config to find the libraries. Make sure that all the libraries can be included properly, and then all the libraries can be linked properly. And I haven't tested this cross-platform, so I need to see, but I believe that should work. That's a generic solution. Okay, I want to start making a function, and I want to call it load frame. So I'm going to say bool load frame, and we're going to give it a file name, and it should give us back an integer for the width, integer for the height, and unsigned char data for the image data. That's what I want to do. And it returns a bool false when it fails. So that's the function I want to create. I'm going to create a new file for that called loadframe.cpp. And it will have that, we'll implement it here. For now, I'm just going to say return false. We just can't do it. In here, after we've created our window, instead of having just creating this data, I'm going to say int frame width, frame height, unsigned char frame data, unsigned char pointer frame data. I'm going to run load frame. I'm going to say users bmj desktop demo song. I think that's it, right? Demo song.mp4. That's what I want to open. And I want to get the frame width, frame height, and the frame data. If that fails, then I'm just going to return 1. I'm going to exit. Printf couldn't load video frame. And so then all of this code, I'm going to change it a bit. So I'm going to change it to the texture width and height will be the frame width and the frame height. And the data there will be the frame data. So the frame that we're loading will then be loaded into a texture, and then we can draw it on the screen. Here we've got to use frame width, frame height. I'm going to remove the... So yeah, pretty basic right now. So in our CMake file, we now have to say that our program, our video app, doesn't just have a main, it also has that loadframe.cpp. So it's going to be 2 files. Once this gets bigger, it's nicer actually to say list, append, sources, and then you have like source main.cpp, source loadframe.cpp. And then for the app, for the video app, I can say it will have all these sources. So you can just list out all your source files there. Okay, so let's remake that and run this. Succeeded. Couldn't load video frame. Good, that's what we wanted because we're returning false. Now in here we could just, to confirm that it's working, we can say create a new, set the width to 100, set the height to 100, and we'll just allocate new data. And then I'll have a pointer, which will be data, start at data 0. And then I'm just going to do int x0, x until less than 100, plus x, y0, y is less than 100. I'm just going to say pointer plus plus equals to, no. I'm going to fill it with just red colors again. But this time written in a different way, like a really short way. Then I'm going to say true. Let's see if that works. So now our load frame will actually just give us a red block. Perfect. So we've got our red block there. So instead of just loading in a red block, I want to load in an actual video file. So let's try that. We'll turn this back into false. And we've got to start including including some of FFmpeg. FFmpeg is all in C, it's not C++. So when including it, I want to tell the compiler, like, the code in here is not going to be C++. Don't think it is. Interpret it as just C code. So I'm going to include the AV codec. I'm going to also include AV format. I'm going to also include, you know what, that's enough for now. I also want to have int types, just to be able to say like u8, uint 8t instead of unsigned char. Like uint 8t is clearer that it's an unsigned integer of 8 bits. Like I prefer that. So int types gives you all of those type names. Okay, how do we open a file? First things first, we want to, the function we want to use is avformat open input. And let me see if avformat open input. Okay, that's the file. So it takes a format context, a URL, an input format, AV dictionary. So we don't want to give it any options. We don't know the input format. We want it to figure that out itself. So those will be null. The URL will just be that file name. And then for the format context, we need to give it a context that it can put the data in. So we start at the top by creating a format context, allocate a context, and we can also check, like, if it didn't allocate a format context, there's something that went wrong. So we can send like printf couldn't create AV format context, and we return false. But if we could create it, we want to give it to our open function here, like that. So we want it to open our input and put the information about that open file into our AV format context. AV format open input will return a boolean or an integer based on if it succeeded or not. So we want to just check that the result we got is 0. Anything other than 0 would be an error message. So I'm going to say couldn't open video file in the case that it's not a non-zero return. Yeah, like in this situation, you might want to like free up the context, because we allocated this context. We might want to free it afterwards. But like if we can't open the file right now, that's an error that will crash the program. We're going to stop the program anyway. So I'm not going to think too much about how to properly like deallocate the resources as of yet. Okay, what I want to do is stop there and run that and see what happens. Couldn't load video frame. Why do we get that message? Because we do all of this and we return false. And then in the main function, we say couldn't load video frame. So that means that we actually could load the video file. We did open it. So I'm going to go into Xcode, go to our load frame function and put a breakpoint at the end there and run it. Okay, so here's the cool thing. We can then look at what AV format looks like. It's a shame that I can't zoom in on this. It's a bit small for you guys to read. But what we have is we've opened it up, and we have a few things that we can look at. We have, let me see. If we go to I format, input format, the name, so it's like an MOV, MP4, M4A. The long name, it's a QuickTime movie. Extension, so it can have an MOV, MP4, M4A, FreeGP extension. But we know that it's a QuickTime MOV file, which is cool. We can also look at duration there. Duration is 2 million. Let me just copy this. That is probably in milliseconds. So if I divide it by 1,000, how is it that long? Is this duration in samples in bitrate 0? Start time, it looks like these haven't been set yet, honestly. So we're not getting much information just from opening the format. We want to actually find some video data inside the format. So we've opened our file. We now want to go looking inside the file for streams, for video streams and audio streams. So the way you can do that is essentially just iterate over all the streams. So inside AV format context, we have a number of streams, and we can access them through AV format context streams I. So let me just say auto stream there, get the stream out, and here I'm just gonna put just a dummy bit of code so that I can put a breakpoint there. So iterating over all the streams. So we stopped here and we have a stream. Stream index is 0. We have a codec. So we can look at the codec. It's an AV media type video. So it's a video. The codec ID is H264. So the first stream in our AV format context is the video stream. I see a width 1920, a height 1080, a pixel format. There's lots of data here that I'm not going to use, but essentially that first stream that we found is the stream that we want to get the video data out of. So how do we turn that into code? We want to say, basically at the end, one of these streams will be the video stream. So I'm going to say video stream index is -1. And I'm going to try and find my video stream, and if it's found, it's like pseudocode, then I'm going to set my video stream index to that I to remember it. I'm going to break out. So if after that loop, my video stream index is still -1, we have never found it. So then I'm going to say couldn't find valid video stream inside file. And we're going to return false. Okay, so how do we check this? So we have our stream. Let me go further through my notes. So we're going to get codec parameters. AV codec parameters. AV format context streams I. Codec par. And then for that codec, we want to find a decoder. AV codec find decoder. So you can see now that after just unpacking the format with libavformat, now we're using libavcodec to unpack the codec within the file. And so given the codec params, codec ID, I want to find if we have a decoder, if we have the code necessary, like we have a program that's able to decode that file. So if we have it, I want to say, like, well, if we don't have it, if we don't have an AV codec, then that's an issue. We probably want to continue looking through all of the streams. Maybe we can find a codec that we can decode. But really, that's not a good sign. You might even want to just break from that. But I'll leave it like that. If the AV codec that we found, if the codec type is AV media type video, we found a stream that's a video stream. You could find the same thing, like one of these streams might be an audio stream, and it would be AV media type audio. And then you can extract stuff like the channels and the sample rate and determine what kind of audio file you're dealing with or audio stream you're dealing with. But if we just found the video, we want to, we found it. Okay, that's basically this code here. We've got our video stream index I, and then we want to break out. But we want to keep both of those. So I'm going to put those outside. AV codec. So that we keep them like that. What's the error? Codec type. What's it supposed to be? Oh, sorry, it's AV codec params. AV codec params is a video. That's how we can find the video stream. So, okay, let's run that again and end at the end there. Okay, so we've blocked. Our video stream index is 0. So we know that the first stream inside the MP4 file is the video stream that we want. So that code works properly. You could also look for, like, I don't want to look for audio, but you can also look for the audio stream index. You can set that to -1, and then you can say, like, if AV codec params codec type is AV media type audio, then we found our audio stream. But then in that case, you wouldn't want to break here. You want to be able to find them both before breaking through the loop, breaking out of the loop. But so I'm going to keep it just as video right now. We haven't used that. Yeah, we don't need that. So yeah, no AV codec, we continue. If we find a codec that's a video, we find a stream that's a video, then we found our stream. Perfect. So I'm gonna start commenting stuff out, commenting some of this stuff. So open the file using libavformat. Find the first valid video stream inside the file. Okay, that's it. Now we have to start doing the real brunt work of taking video data out, getting video data out of getting the actual pixel data out of the video, which means using a decoder or a codec. So, right. This is where it's gonna start getting kind of tough. So all of these things, you have to do every single thing right to get the video file out. And you can just copy and paste this from another project and use that, but if you're gonna really do some video streaming, you have to understand how all of these parts of FFmpeg work together, and you have to call them the right way. But yeah, let me first set up my codec context. So, okay, let's go into here. Set up a codec context for the decoder. So, when you have an AV codec, that basically means you know, or FFmpeg is telling you that it has a program that can decode your video. And what you need to do is, if you want to start decoding it, you have to allocate data, you have to allocate space where it can store its internal data structures for decoding. And that's the codec context. So I'm going to say codec context. I'm going to call that my AV codec CTX. AV codec alloc context free, given our codec pointer. Right, if that failed, if we failed to allocate a codec context, that's pretty bad. So we're going to just print out and say couldn't create AV codec context, and we return false. Right. What now? We have to the information that AV codec, that libavcodec or libavformat, the information that libavformat got out of the file has to be placed into our codec context as its initial state. So we basically do AV codec parameters to context. So we have our AV codec context and our AV codec params, and we're going to load them in. And if that doesn't work for some reason, we're again going to fail. We're going to say couldn't initialize AV codec context. Okay, so if now that that's succeeded, we want to open the codec, the file, and we want to start reading from it. So AV codec open to AV codec context and AV codec, and what's the last option? I've written down that it's supposed to be null, but let me just confirm why. Oh, it's the options. Yeah, we don't have any special options right now. If that is a negative value, that means it didn't work. So I want to just again printf couldn't open codec. Return false. Okay. Oh wait. Okay, so at the bottom here, now that we've done all of that, I'm gonna properly let's see. I'm gonna just write the close input. Just have all the destructuring done. Free the context. AV codec free the codec context. Yeah, so that happens at the end. So we open the file, we find the video stream that we want, and then we open the codec for the video stream. And then lastly, we just properly clean up our routine at the end, freeing up the context that we allocated and closing the input file so that the file doesn't remain open. Right. Oh, okay. That's a lot of stuff. That's the main setup for using libav. Now we want to actually start extracting out data frames from the codec. And that will require knowing a bit about how video files are structured. So how do I explain that? Let me see. Okay, so a video file internally is broken up into different units. Ones are called packets and others are called frames. So a packet inside a video file, basically a video file has all sorts of packets in it, just one after the other, one packet after the other. And the packets come from different streams. So when you read in a packet from a video file, it might be the packet for the audio, it might be a packet for the video, it might be some kind of data packet or something else. When you're looking for the next frame in a video file, you're going to be looking for packets until one of them is a video packet, and then you're going to decode that packet to figure out if there's any frame data in there. And for one packet, there may be multiple frames stored inside it, I believe. But it may also be the case that for one packet, that there are multiple packets that are required to describe one frame. So I'm not exactly sure about the relation between this. Okay, so the AV packet stores compressed data, and AV frame, I believe, would store uncompressed data. Okay. Yeah, so AV frame is the decoded raw data. So we start by getting AV packets out of the file format, and then we put those packets into the codec, into the decoder, and the codec will then give us an AV frame, which will have the raw audio or video data. So let's try that. So first we want to start getting packets out of the data. So let's create a packet and an AV frame. An AV frame and an AV packet that we can use as variables. So we'll have an AV frame, AV packet. I want to allocate my frame. If we didn't manage to allocate, then we want to error, couldn't allocate AV frame. Like with these, I don't really understand why you would. I feel like the program should just crash when you can't allocate a frame or something like this. Like these seem like errors that are never really going to happen. So I don't know why I'm writing them all down. But this is like for every single one of these. Some of these would only fail if you're like out of memory. And I really don't know how often that actually happens, because your computer will just free up memory and put it, like, swap it out to the hard drive. Like you'd have to be in a really bad situation to ever get any of these errors to happen. And if you're in that situation, having an AV codec uninitialized is like the least of your problems. So like the whole rest of the program will never function anyway. So if I would write all of this, I would have just written like, if it was just, if I wanted to simplify it, I would not check for these errors. But for the sake of following the rules, doing what everyone else seems to be doing, I'm going to be checking for those errors. All right. We've got a frame, we've got a packet. So we want to use AV read frame, where we give our format context. Format context, again, is the first thing that we allocated. It's the information about the file that we've opened using a libav format. From that format context, we want to read in a packet. The naming here, I don't understand. Why would you say read frame and then it's actually a packet? Like it should have been AV read packet, right? Why is it read frame? Stupid. That's going to return us a number. If the number is greater than 0, that actually means that that there is a packet that we've read. If it's going to be below 0 or 0, that it's either an error or like an end of file. There's no more packets left. So we're just going to look for a packet. I don't know. Maybe we don't need to do this in a while loop right now. Yeah, we do, because there's situations where the packet, the frame we received is not actually a video frame, so we have to go back through it and read a frame again and do the same code. So we want to put this in a while loop. We want to iterate around until we find our first video frame, and then we can break out. Okay, AV packet stream index. If the stream of this packet is not our video stream, then we're going to continue. We're going to continue looking for others, because we don't care about this packet. We don't care about the audio or any other kind of data. We're waiting until we get a packet for the video stream. And so we'll get to line 71 if it's a packet for the video stream. And so then we want to send the packet to our decoder. And hopefully the decoder will then start processing it and eventually can give us a frame. So we do AV codec send packet. So we give our codec context, AV codec context, and our packet, AV packet. this will return a response. Let's see, int response. If the response is greater than 0, if the response is less than 0, there was an error. So we want to printf failed to send failed to decode packet, and we can get an error string in that situation from, because the response will be the error. We can say av error to string of the response, and we return false. So we're going to get a positive response, and like, how do we do this? So we're sending packets into the decoder, and what we want to do is receive a frame from the decoder. So we're sending the decoder packets, we want them to give us a frame. And so what we can do then is avcodec receive frame. We give it the codec context again, and we give it our frame that we want it to put it in. Again, this is going to give us a response. So we'll have another response here. And so if that response, like there's a few error responses that we might want to deal with, is like if the response is av error e again, or the response is av error end of file, then whatever packet we gave to the decoder, there's no frame inside it, or the frame has already been decoded or something. So we basically want to say, we want to break, we want to continue. We want to go and do another read frame and try and read another frame. So if the response is those two, we just want to continue. But if the response is actually anything else less than 0, then it's actually an error. We want to say failed to decode packet and give the av error to string of the response. In all other situations, we're going to have either the number 0 or greater for our response. So in this situation, we've got a frame. We've received a frame somewhere. So let me just check this all. Yeah, we've received a frame. I'm going to say for now, put that if that's less than 0, and here int response. Yeah, that's why I wanted to use int response, so that we can print out the response. Maybe I'll put that outside there and say response. Send the packet, receive the frame. If av error or av end of file, we're going to continue. If the response is less than 0, we fail to decode. We want to actually return false. There's something wrong. At this point, we've got raw data decoded in our av frame. So I want to just put again like a dummy statement so that I can put my breakpoint there. So breakpoint, let's run this, see how far we get. Ooh, couldn't initialize avcodec context. After I was explaining that this stuff would never happen, it happens. Avcodec context. This might give a positive number as a response, so we have to check if it's less than 0, not if it's non-zero. Okay, we got all the way over here. So we've read in a frame, we've sent the packet, we've received the packet. So if we look at what AV frame has got inside it, it's got some data inside here. Okay, so it's got a data array with 8 entries, and in the first one there's some data, in the second one there's some data, in the third one there's some data. It's telling us that there's a picture inside this. The width is 1920, the height is 1080. We've got a color space, we've got information about the format. So we've got, like, inside here, inside that data, we've got some uncompressed raw data now, which is great. Just to show you, like, let me just explain that. So inside a frame, we have data, and data 0, like the way they decode the pixel data is they have the different channels, like you have a red, a green, and a blue channel. They put those channels in separate buffers. So you have one channel for all the reds, one channel for all the green data, and one channel for all the blue data. In this case, it's not stored in RGB, it's stored in YUV, in YUV, which is like one luminance component for dark and bright, one like hue component for what the exact color is, if it's a red or if it's a blue or if it's a pink, and then a saturation component of how strongly saturated is the color in the pixel. And so it's broken up in a different way. It's not just components of red, green, and blue. But the luminance one, we can use that to get a grayscale image. So before doing any complicated processing, I'm just going to break out here. And before I break, I'm going to basically, when they give you a packet, it's reference counted. So what I want to do is packet unref the AV packet and say, I'm not, like, you gave me an AV packet here, I'm not using it anymore, so I'm going to unref it. Here, what I also want to do is AV frame free, and give my frame an AV packet free, and give my packet. So I'm going to free up all my resources. But before, I'm going to break out, and here I've got an AV frame, supposedly. So my AV frame, I want to get the data out of that and put it into a square so I can put it on the screen. So first I'm gonna allocate some data. So unsigned char pointer data is new unsigned char array with the width and the height of the frame. Width times AV frame height times 3 pixels for each. We're going to make RGB data. And then I'm going to basically just copy over. I'm going to have a Y. I don't care about the efficiency of this. An X that goes from X to whatever the width is. And a Y frame, whatever the height is. And then we're going to fill in our data here. So, oh, is this a redefinition of data? Up here, I'm going to say width out, height out, data out. So the parameters there are not mixed with our code over here. So we're going to have our data. I'm going to say Y times AV frame width. Oh, let's see, AV frame width times free plus X times free. That's going to be our red component, our blue, our green. So now our data doesn't have any actual data. It's still a red block, but it will have the dimensions of our frame. So let's just return that real quick. We're going to say width out will be AV frame width. Height out will be AV frame height. And data out will be our data. So let's see if that works. I hope it does. Couldn't load video frame because I returned false. So I have to return true there. Okay, that's big. Oh, there we go, yeah. That's 16 by 9. So that's the video frame. We've loaded well, it's not the video frame, it's just red. Let's get the actual data out. For the time being, I'm just going to extract the data from the luminance of the frame. So we're not going to get the color because we need to convert color space properly to actually get a color image on OpenGL. But I'm just going to get the black and white image. The way I can do that is the way the data is stored inside AVFrame is, if you see again, so inside AVFrame there's a data. Let me pause it here. Let me put a breakpoint there so we can see. Inside AVFrame, we have these data components. We have data 0, data 1, data 2, which correspond to the luminance, the grayscale color component, the U, and then the V, like the color components there and the grayscale components. And in those arrays, all of the data is stored consecutively. You just have one byte after the other. And so at some point, you basically start in the top right corner of the video and you have all of the video pixels. And then at the end of that line of bytes, you start describing the pixels on the second line of the video, on the second horizontal, then the third, then the fourth. And so there's another variable we need to be able to turn this one buffer into an image, which is how many bytes are there per line. And that's described in line sizes. I hope you can see this, like it might be much too small. But inside line sizes, for each piece of data we get the line size. So it's telling us for that luminance data that the line size is 1920. That if you want to get the first pixel of the second line on that video file, you will have to look at byte number 1920. If you want to get the second pixel, it would be byte number 1921. So we can use that to extract out the data. So I'm going to say here in my code, let me switch back to this for a second. I'm going to say in my code that we want to get AVFrame data 0, and we want to extract out whatever the Y value is times by AVFrame line size 0 plus X. That's going to be the grayscale pixel data for X. And we're just going to put that in the R, the G, and the B to just get a grayscale image. And so let's have a look at that. Let's see if that runs. Okay, it does. And so we're getting the data from the sample image, but it's upside down. So why is it upside down? I guess I could just flip it in OpenGL. I'll flip it in OpenGL. So in OpenGL, when I say ortho, I can say that when you refer to 0, you're actually referring to the window height. And when you refer to the window height, it's 0. Let's flip around our projection. Yeah, there we go. Black and white data. Okay, so that is the first frame of the video loaded in and rendered onto an OpenGL surface, but it's only the black and white data. So that's a good intro for now. I'm going to take another break, and then I'm going to go into using the FFmpeg library swscale, which here, like, it's apparently, like, within FFmpeg, within the developers, they don't really like swscale. But we're going to use the swscale library that comes along with FFmpeg to do color conversion, and you can do scaling with it, but we're not going to scale the pixels. We're just going to do color conversion to turn a YUV video, a YUV pixel video, into an RGB frame.